Guys, Mr. Bowman here. In this video, we're going to be looking at 2.12 probability methods, and we're focusing on all the excellence questions from the 2018 exam. So let's jump into question number 1. So each day, temperatures are recorded at various locations around New Zealand. The National Institute of Water and Atmospheric Research obtains daily temperatures by finding the mean of all of the recorded temperatures in one 24-hour period. Over the last 7 years, the temperatures in Reefton have been found to be approximately normally distributed. I like seeing that. That just confirms it's a normal distribution question, with a mean of 11.6 centimeters and a standard deviation of 4.8 centimeters. Using this normal distribution approximation, the probability of a daily temperature lower than 6 degrees, so probability of 9 degrees or less, is 29.4%. Suppose that the temperatures in Reefton increase due to climate change. So what that means is there's been some kind of change, which means ordinarily the standard deviation and the mean would change as a result. Standard deviation remains the same. So that's nice to know that the standard deviation is the same, but the mean above here has changed. What would the mean daily temperature be for Reefton? To become, or to make this to fall below 20%. And just noting, that word "this" refers to the lower than 9 degrees reference before. So let's get into it. Let's draw a normal distribution curve. That's always where I suggest we start with these questions. So there's my curve. I've been told the standard deviation is the same, so that's 4.8. The mean is what we're trying to calculate. So we've specifically been asked, well, what's the mean? And we've been told, or we're trying to find out if it is 9 degrees or lower, so that would be this area, when would the probability become 20%? So when would it fall to 20% at that 9 degree number? So this question here, basically we've been asked to find the mean based on the changes that they've talked about into the question. Once you've done that, the first step you need to do is draw a standard normal curve, and your goal is to find the z value that relates to the 9. So there's our z value. We know that there is 0.2, so that area hasn't changed. We know the the standard deviation in a standard curve is equal to 1, and the mean is equal to 0. We plug that into our calculator, so we know the tail. So we're using the inverse function. Tail is equal to left. The area is equal to 0.2. The standard deviation is equal to 1, and the mean is equal to 0. If you put that in your calculator correctly, you should be getting a z value. So z is equal to negative 0.8416, and that there had a 4 dp rounding. When you get your z value, normally makes sense to have a bit of a sense check. And we can see this is 0, which means our z value is below that. That tells us it should be a negative z value. If it was on the other side, if it was over here, that should be a positive z value. So ours is negative, so we're probably all good so far. Once you've got your z value, you then need to link that to the z formula. So z is equal to x minus the mean divided by the standard deviation. We have the z value, we have the x value of 9, and we have the standard deviation. So those three circled parts, we're going to put them into the z, the x, and the standard deviation. That leaves just the mean in our equation. We can use the solver function on the calculator or a bit of algebra to go ahead and solve for that. So negative 0.8416, that's going to be equal to 9 minus the mean divided by 4.8. Just a reminder, for the calculator, you're probably going to need some brackets up the top there. Put that into the calculator, and we're going to be told that the mean is equal to 13.04 degrees, and that there had a 2 dp rounding. So what this number means is if the mean drops to 13.04 degrees, there will be a 20% chance that the daily temperature will be lower than that 9 degree threshold. We are now on to question number 2, and question 2 is an interesting one. It's one of the few exam questions that I've seen where there's no context and it's just about the normal distribution, the interquartile range, and the standard deviation. So I suppose the interquartile range, if you remember from maybe the inferences internal you might have did, is just a box and whisker graph. And the interquartile range is that's the lower quartile, that's the upper quartile. So the interquartile range, oh gosh, I've got the abbreviations the wrong way around. There you go. Interquartile range is equal to the upper quartile minus the lower quartile. And the key thing to note here is each quarter of this graph represents 25% of our data. So what that means is this interquartile range number actually represents the middle 50% of that particular data. So what we're going to do is we're going to use that to construct a normal distribution curve. So there's a normal distribution curve, and we'll have our lower quartile down here somewhere. We'll call that x1 because we don't know what that is. And we'll call that x2 over here because we don't know what that is. But that's the lower quartile and that's the upper quartile. And we could make up some numbers here, just run with them. But what I'm going to do is I'm going to use a standardized normal distribution curve just because everything standard makes it easier to understand. So the standard deviation in that case will be 1 and the mean is 0. And as we said, we know that the middle 50% or the value between the upper and lower quartiles, that's got an area of 0.5. So we're now going to jump into finding out what these two x values are. And if you put that into your calculator, it's just a regular inverse question. So we're going to have a tail. It's one of the few times we've used the center part of the tail. It's going to have an area of 0.5. It's going to have a standard deviation of 1. It's going to have a mean of 0. Plug that all in. We're going to say x1 will come out as negative 0.675 or 45. And then the second value for x will be positive of the same number. And that makes sense because they're both 25% away from the mean, so they're the same distance away from the mean. So one should be positive, one should be negative. And I should note both of those had a 4dp rounding. So we've got the x values, and we're now going to link that back to our interquartile range question. So we knew the interquartile range was going to be equal to the upper quartile minus the lower quartile. And we've got our two quartiles up here. So 0.6745 minus negative 0.7645. Minusing a minus becomes positive. And when we add that up, that becomes 1.3490, and that had a 4dp rounding. So this here tells us the interquartile range, and we have the standard deviation up here. So if we go back to the question, it said, show that for any normal distribution, the interquartile range is greater or always greater than the standard deviation. And what we're going to do is we're going to compare these numbers because this is a standardized normal curve. This could be any data set. And in a standard curve, if the standard deviation is less than the interquartile range, we've shown what they've asked for us. So in our case, we've got the interquartile range is greater than the standard deviation, and that's because 1.3490 is greater than 1, which means, therefore, the interquartile range is always greater than the standard deviation. Yeah, so as I said at the beginning of this question, it's a weird question, one of the few I've seen without context. Yet to really be on point with your understanding of the conceptual part of a normal distribution curve and a box or whisker graph to be able to get on top of this question. We are now on to question number 3. Matua wants to complete or compare weather with Kaitaia and Reefton. So we've got that weather theme from this exam where his brother Tamati lives. He performs the same analysis on the weather data for each town, and he's got the summaries below. So he's done the summary from the previous questions. This is the data he's got. He claims that it is 20 times more likely to be windy in Kintyre than it is in Reefton. Use this information to explain whether the claim is correct or not. So the first thing we need to know is when it is dry, so we're only interested in the dry days for each of these cities. We're curious about how windy it is when it's dry. So let's start off with, I'm going to write K for Kintyre, and we're trying to find out, well, what's the probability that it is windy given it is dry on that particular day? And that just goes, so when it's dry, what's the probability that it's windy? So for this, we're going to use our beloved F over T approach, which I really encourage for these questions. So first thing, we've got Kintyre and dry days. How many dry days are in Kintyre? We've got 1,915. So that's our denominator, 1,915. Of those days, how many of them are windy? 1,093. And you plug that into your calculator, we're going to get a probability of 0.5708, and that had a 4 dp rounding. We're now shifting to Reefton, and we're doing the same thing in Reefton. What's the probability that it's windy when it is dry there? And let's have a look, F over T again. So we're now down to Reefton. How many dry days are there? 1673. So that's our denominator, 1673. And of these dry days, how many are windy? Only 53. So quite a small number. Put that into your calculator. You're going to get a probability of 0.0307, and we had a 4 dp rounding. Once we've got that, we're making this comparison 20 times more likely. When that happens is that's normally talking about relative risk. So let's jump in. Let's find the relative risk of these. And don't forget, relative risk, I encourage to go the big number divided by the small number. And that's because it's just easier to explain. And the big number is on the top up there, so that's 0.5708. So 0.5708 divided by 0.0307. And when you put that into your calculator, you're going to get 18, and that there was rounded to the nearest whole number, which is 0 decimal points. So that number 18 tells us it is 18 times more likely to be windy in Kintyre when it's dry compared with Reefton. So this tells us that it is 18 times more likely to be windy in Kintyre than compared with Reefton. So at this stage here, if you stopped, you're probably going to get a merit, and that's because you haven't answered the question. The question was whether or not you agree with the claim. So it's been claimed that there is 20 times more likely, and I should note, while 18 times is significantly more, so it's definitely going to be windier in Kintyre compared with Reefton. I should write when it's dry, actually. When it is dry. It's not 20 times more likely, so it's pretty close to 20, but not quite. I therefore disagree. Oh, so maybe we should say, while it is far more likely to be windy when dry in Kintyre compared with Reefton. The claim, so I'm going to put the person's name, is incorrect. So maybe if that 18 number was something like 19.8 or getting real close to 20, you could probably say, oh, yep, he's all good. But this time around, 18 is just a little too far away from 20 for my liking. So I'm going to state that the claim is incorrect. Nancy has found some data about Ashburton and Timaru over the last 7 years, and we've got some proportions about it being wet in Ashburton, and then if it's wet in Ashburton, you've got some information about Timaru. If it's dry in Ashburton, you've got some information about Timaru being dry as well. So we're planning a one-day bike ride from Ashburton through to Timaru and then to Waimati. The grandfather says, in his experience, the probability that it will be dry in all three towns is between 30% and 35%. On the day that it is decided to ride, it is dry in both of these towns. If the grandfather is correct, what is the smallest probability that it's going to be a wet day in Waimati? So, question 4, we're going to start off by drawing the probability tree representing this scenario. So we're only really interested in the Ashburton dry and then Ashburton wet. So, for example, we already know it's dry in Ashburton and it's not wet, so we don't really need to carry on in this direction. And we know that had a probability of 0.45. Oh gosh, right, that was the wet probability. So that their probability of it being dry is the remainder, 0.55. After that, we then have to explore Timaru being dry and Timaru being wet. And like the other Ashburton being wet one, we could split it off more, but we don't need to explore that. We're just going to focus on the Timaru being dry if Ashburton was dry. So if Ashburton was dry, the probability that Timaru was dry was 0.88. And then finally, we're going to that third town. I'll just call it Y for shorter, dry, and wet. And we are trying to find out the probability that relates to that dry, or actually the probability that relates to the wet branch. But we've been told the probability at the end of it being dry in all three towns is somewhere between 30%, which is 0.3, to 35%, which is 0.35. So that's the probability range we're going to work through. And we need to, or our plan is we need to work backwards to find the dry probability. And then from that, we can work towards the wet probability as well. So the way I'm going to approach this question, I'm going to break it up into two options. So let's say it's the lower limit of 0.3. So 0.3, we know that this, which we don't know, so we're going to call that x, is going to be equal to 0.3. So we've just got an algebraic equation. So 0.55 times 0.88 times x is equal to 0.3. I'm now going to use my algebra, so I'm going to go divide by 0.55 times 0.88. And I'm going to do the same on the other side as well. So x will be equal to 0.3 divided by 0.55 times 0.88. Just a reminder, if you're putting that in your calculator, do put some brackets down the bottom. And based on that, x is going to be equal to 0.7576, and that there had a 4 dp rounding. Put the 4 dp on the side over here, 4 dp. I'm now going to consider the same for this 35% probability. So let's say we're aiming towards 35%. This is the exact same approach, except we're subbing out the 0.3, putting in the 0.35. We're going to have 0.55 times 0.88 times x will be equal to 0.35. Same algebra applies. X will be equal to that number, 0.35, divided by the other two multiplications. 0.55 times 0.88. And when you put that into your calculator, we're going to get a number of 0.8838, and that had a 4 dp rounding. So just to note, if you're not too confident with your algebra, that initial equation, or both of the initial equations that we came up with, you can plug that into the solver function of your calculator, and that'll get straight to those final answers that we're looking for. So those values that we've found out, so that relates to the probability of it being dry. So that means the probability, or carrying on from each of them, So the probability of Y being wet is going to be 1 minus the probability of that being dry. And we've got that probability over here. So that's going to be 1 minus 0.7576. And that there is going to get us to 0.2425. We now need to do the same below. So the probability of Y being wet is 1 minus the probability of it being dry. Our probability being dry is slightly different because we use that different estimate, 1 minus 0.8838. And we put that into our calculator, we're going to get 0.1162. And those two numbers here, they're the probability of it being wet in Waimate. And once you've got that, we can link it back to the question, what's the smallest probability of it being wet in Waimate? So smallest probability of being wet. So of being wet in Waimate is 0.1162. And that was the smaller of the two circled numbers we've got down the other side. Question number 5 is the last question, or the last excellence question from the 2018 exam. And just for your reference, I've given you the example, the answer to AI from an earlier question, because in this question you are asked to refer back to that in discussing your viewpoint. So Terry, who is Nancy's friend, has found out that 45% of the days in Ashburton are wet and 35% in Timaru are also wet. Terry's constructed a probability tree, so she's gone Ashburton, wet or dry, and then off that, using her numbers, Timaru, wet or dry, Timaru, wet or dry. Explain why Terry's tree diagram would not give the correct answer. In your justification, you should figure out the answer that Terry would get from her tree and consult the map that we're given over here. So the map's a bit difficult to see on the screen, but first thing is let's find out, well, what's the probability that they're both going to be dry? And this is based on Terry's numbers. So both dry, it's going to be 0.55 times 0.65. So 0.55 times 0.65, and that gets us to 0.3575. And if you have a look or compare that with the other number, that's well over 10% off. So it's about a 13% difference. And that's a huge variation from two people who got it from the same data set. So they all got it from Niwa. Why has it gone so wrong? Once we've done that pretty basic probability part, the rest of the question is now wordy. So we're going to start off with just by saying there is a significant difference between Nancy and Terry's answers. We'll spell Terry wrong. So that's our first thing. We're stating that there's a big difference. And the key thing to note is the question's kind of suggested that Terry's wrong. So it's saying Terry's answer is not correct. We've now got to think of reasons why. So the first thing to note is Terry's probability numbers, they're two separate numbers. And you'll probably say it's too simple because her numbers don't reflect. So Timaru and Ashburton, they're pretty close to each other. So we've got Timaru over here, Ashburton over here. So in terms of the South Island, they're really close. And there's probably going to be a relationship. If one is wet, the other's probably going to be wet. So that same weather patterns are going to impact both at the same time. So by just multiplying the two numbers together, her approach is going to be too simple. So I'm going to say Terry's approach is too simple. The probability of it being wet in Ashburton, so the probability of it being wet in Ashburton will be related. And that idea is, as soon as something's related, you do have to change your approach of calculating probabilities. It's probably related to the probability of it being wet in Timaru. So probability of it being wet in Timaru. So we now got to explain, well, why are they related? And that's when we go into how close these two towns are. So based on our map, Ashburton and Timaru are really close to each other. And we would expect them to have similar weather patterns. We would expect them to have similar weather patterns on a given day. So, and I guess the summary, we're trying to say Terry shouldn't use the simple averages that she's found above. So she shouldn't really use these simple numbers. She should consider using conditional elements or conditional probability. Terry should not use simple averages and should of incorporated conditional probabilities. Conditional probability. So, yeah, wordy question comes up at excellence levels from time to time, so make sure you're prepared for them. And that wraps up all the excellence questions from the 2018 exam. Hopefully you found them useful. Keep an eye out for the other videos and the other activities to revise for your exam.